Hi, so in this session we are going to start coding our binary search algorithm. Okay, so we can start with the binary search code, and I think in the binary search the condition was that our array should be sorted. Okay, so let's just take an array and let's say array is 1, 4, 7, 10, 20, 35, 40, something like this, right? And we will be implementing a binary search. So we will be getting an index, calling this binary search function, right? And this binary search function takes an array and the element which we need to search. Let's search for 7 for now, and we will just print out the index. That index is plus index, something like this. So if you want to print the index, our function will be this: public static int binary search. It takes an array and it takes an element which you need to search, and this is the function you need to implement. Okay, so this will return the index. If the element is found, then it will return the index corresponding to that element. If the element is not there, it should return -1. Okay, so if this array is given to you, that is 1, 4, 7, 10, 20, 35 and 40. Let's say we want to search 7 here. So I think what we had discussed was that we will maintain initially start here and an end here. Okay, so let's just do that, and let's say our start is initially 0 obviously, and our end is last index. Last index is actually array.length -1. Okay, array.length -1. So we will write the while condition that we will keep on doing something one by one, but I think the first task was to find out the mid element. The mid is actually start plus end divided by 2, right? So here it is 0, 1, 2, 3, 4, 5, 6. We will do 0 plus 6 divided by 2, that is equal to 3. We are starting at this mid index. Now what we have discussed is we will compare this mid element with this element. Here the array at mid is actually greater than the element. So what we need to do? If array of mid is greater than the element, I think 10 is greater than 7. So obviously 7 will not be in the right side. Start will be here. We need to search in this part of the array. So our end will move on to this here. That means end should become mid -1, right? So I think we can write that if array at mid is greater than the element, then simply we can say that our end will become mid -1, right? Now here end has become this. We are searching for 7. This is start and end here now. Now what you will do is again calculate the mid start plus end divided by 2. So this will be 0 plus 2 divided by 2, that is equal to 1 here. You will come to 4. Now 4 is lesser than 7. That means the condition should be array at mid is lesser than the element. Since 4 is lesser than the 7, I think element cannot exist in this left part. Only in this right part element can exist. So start will become mid +1. End will still remain there. The start should move on here. So I think the condition should be else if array at mid is smaller than the element, that means your start should become mid +1. Else, let's see this 1, 4, 7, 10, 20, 35, 40. Now start and end both are here. That means at 2th index. So now if you take the mid, it will be 2 plus 2 divided by 2, that is equal to 2. Here array at mid is not greater than the element. 7 is not lesser than 7. 7 is not greater than 7. Actually 7 is equal to 7, and you are standing at that index only. That means your answer is there. That means you can just return the mid index. you can just return the mid index from there and you are getting your answer, right? So let's say if I have searched this 1, 4, 7, 10, 20, 35, 40, why I have written mid here? Because if it is 0, 1, 2, 3, 4, 5, 6, if I have told you to search 10, 0 plus 6 divided by 2 is 3, array at mid, if I am searching 10, 10 is not greater than 10, 10 is not lesser than 10, 10 equal to 10, you can just return the mid index from there because your answer is 3. You don't need to move start and end here and there now, you can just return from there, right? Now the important condition is, what will be this condition? Let's say if I want to search 15 here, what I will do is 1, 4, 7, 10, 20, 35, 40, start and end will be here, mid will be this 10, 10 is lesser than 15. So obviously 15 will exist in this right part. I will go to 20, 35 and 40. These index are 4, 5, 6. Calculate the mid index. 35 it is there. 35 is greater than 15. So obviously I will say it will exist in the left part. Now I will have only 20 as the array. This is your start and end. 20. 20 is greater than 15. You will move on to the left part. That means your end will become mid minus 1. Start will still be 4 because this is my 4th index, but end will become mid minus 1, that means end will become 3. Start has crossed end, that means no part of the array exists now, that means your answer is minus 1. So we have to search only till start is lesser than or equal to end. If start has crossed the end, you cannot do anything, you can just return minus 1. If anywhere you will be able to find the element, the mid will be returned from there, that is the index. If you are not able to find out the element, that means start has crossed the end, that means your answer is minus 1. Okay, so this is the simple algorithm and this is a simple code for binary search. If you run this, let's say we are running this, so if we run this for 7, your index is 2. Index is coming out to be 2 and 2 is the index. If you run for 35, your answer is 5, which is correct. 0, 1, 2, 3, 4, 5. If you search for, let's say 30, your answer should be minus 1 and your answer will be minus 1. Okay, so our function is working out perfectly. This is the code for binary search. Make sure you understand this by heart, because this is very, very important. Binary search itself has lot of application. So make sure you understand this binary search thoroughly. Okay, great. Thank you.